Good morning. Let us begin our session. So today we'll be discussing about Kubernetes. So in the previous sessions, you might have seen, like we had a discussion about Docker. So we know how to convert the Docker file into Docker images. So let's understand the Kubernetes also, how actually the Kubernetes uses Docker images. And we will start with like what is Kubernetes, first of all, what is Kubernetes and what are the features of Kubernetes. And we will also understand the architecture of Kubernetes. Okay, we'll also understand the architecture of Kubernetes. That's the agenda for today's session. So let's start with what is Kubernetes. So, uh, for example, like if we wanted to learn Kubernetes, the prerequisite for learning Kubernetes is Docker. Since we have understood what is Docker, we are going through the Kubernetes. Prerequisite for learning Kubernetes is Docker. And the very first point, okay, the prerequisite for learning Kubernetes is Docker. We should understand or we should have a clear understanding on Docker if we want to learn Kubernetes. And who created this Kubernetes tool? Google organization. Okay, Google created this Kubernetes and it is an open source tool. You know the meaning of open source tool. It is freely available. We can download it and we can install. We can set up this Kubernetes for free of cost. So Kubernetes is called as K8s. K8s in the sense like there are 8 letters. If you see the spelling of Kubernetes, there are 8 letters between K and S. That's the reason why in a short form, Kubernetes is called as K8s. There are 8 letters between K and S. That's why it is called as K8s. It is shortly called as K8s. And we have seen like earlier, when we were discussing about the tools, we understood like Git is a source code management tool. Jenkins is a CI/CD tool. Maven is a Java-based build tool. Docker is a containerization tool. So for each and every tool, like we have understood, Docker is a containerization tool. But when we come to the Kubernetes, what is Kubernetes? Kubernetes is container orchestration tool. Kubernetes is container orchestration tool. So we'll understand the meaning of container orchestration. Anyhow, we will understand the meaning of container orchestration. But before that, try to understand the basics. Google created this Kubernetes. It's an open source tool. Prerequisite for learning the Kubernetes is Docker. We should have a basic understanding of Docker to learn Kubernetes. And Kubernetes is shortly called as K8s because there are 8 letters between K and S. It is a container orchestration tool. Meaning of container orchestration, we will understand. So try to understand that there are some features for the Kubernetes. Okay. So if you are learning about any particular tool, definitely we should have understanding on what are the features, what are the advantages of having Kubernetes on that. So let's understand what are the features of Kubernetes. Okay. So usually before we understand the Kubernetes architecture, let's understand the features of Kubernetes. Let's understand the older approach and how we are doing it today. Consider you have a Consider we have a Java artifact. Okay. So usually we have taken an example of Java application only, Java web application only. Now consider we have built the Java application and we got an artifact. Consider we have an artifact. So you know how to generate an artifact and all. We use a build tool like Maven. There are many build tools, but we have used Maven as a build tool. Consider this is an artifact. Okay. You can take any name of the artifact. I'm just taking the artifact is in the form of var. Consider I have an artifact and I'm going to, if I'm having an artifact, usually the older approach is in the servers. Okay. In the servers, we used to install, Tomcat. Consider this is a server. Either it's a Linux or Tomcat server. Just consider this is a Tomcat server. How it is called as Tomcat server? It is called as Tomcat server because Tomcat package is installed here. Tomcat software is installed here. That's the reason why it is called as Tomcat server. So what I'm doing is we are going to deploy this artifact. We are going to take this artifact and I'm going to deploy this artifact inside the Tomcat server so that our application we can see our application up and running. This is the older approach that we were doing. And you can understand here, suppose if this particular server, whatever the server we are now talking about, the Tomcat server, if this particular server will have a limitation, this particular server will have a limitation. Consider this particular server cannot handle more than some 100 requests. Okay, this particular server cannot handle more than 100 requests. What do you mean by request? So if any if any if anyone wants to access the application, usually they have to connect to the Tomcat server and they have to access the application. And consider there is a limit. Okay, this Tomcat server can able to handle only 100 requests, meaning if more than 100 people tries to access this application, which is running in this Tomcat server, so this Tomcat server cannot handle, this server cannot handle, this particular server cannot handle more than 100 requests. So if it is not able to handle more than 100 requests, what we have to do, we need to take one more server and we need to install the same Tomcat package inside this server also. Try to understand. We need to install same Tomcat package inside the server also. We need to make this as Tomcat server. Again, this server capacity is also some 100 requests. Okay. This server capacity is also 100 requests, meaning more than 100 people. Okay. More than 100 people could not access the application from this server. Okay. So now we have two servers. One Tomcat server can able to handle 100 requests. At the same time, another Tomcat server can also able to handle 100 requests. Totally, how many people can able to access the application at a time? 200. 200 people. So one request, we are talking here, one request means 100 requests means 100 people can able to access. So totally two servers are there. Each server can able to handle 100 requests, meaning totally 200 people can able to access this application. Suppose if the traffic is increasing, meaning if uh, during some times, if more than these 200 people are trying to access this application, definitely what we have to do is we need to keep one more server. Definitely we need to keep one more server. And again, we need to install Tomcat server. We need to install Tomcat package in it. We need to install Tomcat and we need to make it as Tomcat server. And also understand we are going to maintain the same category of servers. That's the reason why we can say this server will also handle some 100 requests. Okay. So like this, we need to keep on adding. We need to keep on adding the servers. We need to keep on adding the infrastructure. If the traffic increases, traffic in the sense, people who are accessing the application, the number of people who are accessing the application, who are using the application increases, then definitely you have to increase the servers like this and you need to install your application. You need to install Tomcat. At the same time, you need to install your application in the servers. Then only the public can able to access your application, right? That's how actually the things will go. So now, okay, this is an example to understand. This is an example to understand the load actually. So here in this particular example, we have taken three Tomcat servers, three servers. Each server can able to handle only 100 requests. Okay, each server can able to handle 100 requests. So what is the load here? Totally, all these three servers together can able to handle 300 requests. Why? Because we have three servers, each server can able to 100, can able 100. So totally all the three servers can able to handle 300 requests. So this is how usually the load will be calculated. Suppose if another request has come, if more than 300 requests comes, what happens? If more than 300 requests comes, definitely we have to, okay, definitely we have to keep on increasing the servers like this. This is the only way. We have to keep on increasing the servers or otherwise we need to increase the configuration of the servers. This is the only way where we need to keep on adding. This is the older approach, okay, where we were installing our applications, where we were deploying our applications. Okay. So now we are not deploying, just assume that we are not deploying into any of the Tomcat. We have an advantage of Kubernetes. Okay. Any application, either it's a Java application or .NET or any type of application, now we are deploying any category of application. We are following the concept of Docker. Whatever the artifact that is generated, what we are doing is we are converting that artifact into Docker image. And if the Docker image is ready, we can deploy the Docker image into Kubernetes, any type of application, irrespective of the technology. Like either you are generating an artifact for the Java, you're generating an artifact for .NET, you're generating an artifact for any kind of Node.js application, whatever it is. Usually, we will convert that into Docker image. Finally, that Docker image will be pushed into the Kubernetes. That's how the the latest trending goes. So let's understand the Kubernetes approach also. What actually we do in the Kubernetes. I just wanted to take a new one. Let's say here I'm just taking a new one. So in the same way, try to understand how we have understood the older approach of deploying the application into the Tomcat server in the same way. Consider how we are deploying the applications into the Kubernetes. What is Kubernetes? Kubernetes is nothing but, you see, if this is a Kubernetes, what is this Kubernetes? Why we are, actually, we need to understand what is Kubernetes, right? So the actual Kubernetes architecture is like, we will be creating a cluster, okay? We'll be creating a Kubernetes cluster. So what is a cluster? Cluster is nothing but a group of machines. Consider the size of this cluster is 3. The size of this cluster is 3, meaning we'll be having 3 machines. Here, usually the terminology we use for calling the machines as nodes, okay? Consider this is node 1 and we have node 2 and node 3. This is the cluster size of 3. So when I talk about cluster, when I talk about Kubernetes, usually the immediate thing that comes into your mind is cluster, Kubernetes cluster. What is Kubernetes cluster? Cluster is nothing but a group of machines. Cluster is nothing but a group of machines. So before you create a Kubernetes cluster, we need to specify the size of the cluster. Suppose if the size of the cluster is given as 2, 2 nodes will be created, 2 machines will be created. And if the Kubernetes size of the Kubernetes cluster is 3, usually 3 nodes will be created. So based on the size you are giving, the cluster will be created. Consider we are giving a size of 3, 3 nodes are being created, 3 nodes are getting created. So now we are going to deploy we are going to deploy all our applications into this Kubernetes cluster. Consider if I am having a artifact, usually if I'm having an artifact, that artifact will be converted into Docker image. Okay, I'm just having like artifact.var, whatever it is. Okay, I'm just taking an example of var package. You can assume you can take either ER package or jar package or anyone you can assume. So now what I'm doing is like the same way I'm going to convert this into Docker image. It is mandatory. See, for the older approach, we have not converted into Docker image. So there we are not using any Docker concept. We are not following any Docker implementation. But here we should implement the Docker technology. We should convert the artifact into Docker image. Finally, once we have the Docker image, this Docker image will be deployed into the Kubernetes cluster. So if you ask me, this Docker image can be deployed into the Kubernetes cluster. Cluster is nothing but here we are having 3 nodes. Cluster is nothing but like here we are having 3 nodes. So we can deploy this into any of the nodes. Like we can deploy into node 1, node 2, node 3. If I deploy this Docker image, this can go and deploy into any of the nodes. Okay, node 1, node 2, or node 3. 3 nodes we are having. This particular image can go and run as a container in any of the nodes. So actually in the Kubernetes terminology, in the Docker, as per the Docker concept, we used to call it as Docker container, but we should not call that as a Docker container here. Anyhow, the concept is if you run this Docker image, okay, we are going to run this Docker image. We are going to convert the artifact. We are going to convert the artifact into Docker image. We are going to push this Docker image into, we are going to deploy this Docker image into the Kubernetes cluster. Anyhow, if I deploy this Docker image into the Kubernetes cluster, so this is going to run in the form of a Docker container, but we should not call it as a Docker container. The terminology is different. We should call it as a pod, POD pod. So this Docker image is going to run in the form of a pod, POD pod, okay? I'm just mentioning that, I'm just giving the name for this one, okay? This is going to deploy and it is going to run in the form of a Docker container, which is called as a pod. You can assume the Docker container is similar as the pod is similar as Docker container. Okay, it is going to run in the form of a pod. What is there inside the pod? Inside the pod, we have Docker container only. Nothing is there. But as per the Kubernetes, we are calling it as a pod. The terminology that we use in Kubernetes is pod. But what is there inside the pod? Docker container. So you might ask me a question like how many pods we can run? Suppose consider if pod is running. If a pod is running, it doesn't mean that the public can able to access. Okay. If a pod is running, it is nothing but your application is running. Your application can be accessed by the public. And this pod will also have limitations. This pod will also have some capacity. Consider this pod can also handle only some 100 requests. Okay. This pod can also handle only some 100 requests. If pod is running, it is nothing but your application is running. This pod can be accessible by the public so that they can able to access the application. And this pod will have some capacity, like it can able to handle only certain amount of requests. Just consider that this pod can able to handle only some 100 requests. What we are going to do? If this pod is going to handle only some 100 requests, assume that the capacity of the pod is only 100 requests. What we are going to do is okay, this pod is going to handle only 100 requests. What we will do is we will be increasing. Okay, we can create one more pod. It is in our hands. That is the beauty of Kubernetes. Like we can create one more pod with the same application. Okay, with the same application. So with the same Docker image, with the help of same Docker image, we can create same replica. Replica is nothing but same copy of this pod. We can create the same copy of the pod. Why? What is the necessity? Why we are going to create the same copy of the pod? This pod can able to handle only 100 requests, but I'm getting the load more than this 100 requests. If I'm getting more load than this 100 requests, then definitely I will be creating one more pod, and this pod will also handle some load. Assume that this pod will also handle some another 100 requests. This pod will also handle another 100 requests. So if we are getting still if we are getting more load than 200, totally two pods are there. Each pod can able to handle 100 requests. Now, if we get more than 200 requests load, definitely we can go ahead and create, we can go ahead and create one more replica of the same. With the same Docker image, we are going to create one more replica of the same. So this is the advantage of Kubernetes. Like, so if the load increases, we can increase the number of replicas. If the node increases, we can increase the number of replicas. You see, there will be no downtime, the Kubernetes, what happens if the pods are running? And usually, all the pods will not run in the same node. All the pods will not be running in the same node. We can create some pods. Usually, if you create some 5 pods, usually pods will be distributed among the nodes. Some pods will be created in node and few pods will be created in node 2, few pods will be created in node 3. This is one advantage actually. So even though if node 1 fails, if something happens, if there is some issue, okay, if there is some issue with the node 1, if the node 1 fails, and we have two other nodes, node 2 and node 3. there also our pods are running, and these pods can able to handle our application. That is the beauty of Kubernetes. Hope you understood. Like based on the load, we can increase the number of replicas. Here we are calling them as POD pod. It is similar to the Docker container only. See, if we are having an artifact, we are going to convert that artifact into Docker image. We'll be deploying that artifact. We'll be deploying this Docker image into the Kubernetes in the form of a pod. If a pod is running, it doesn't mean that your application is running. And this pod will have some limitations like this pod cannot able to handle the entire load. If this pod is handling some 100 requests, so the another pod can be created with the same Docker image. Another pod can be created, and that pod will also share the load. Like this, the load can be whatever the load that is incoming. That load can be handled by creating multiple replicas. This is the actual concept that you need to understand from the basic idea. Okay, if we want to understand the Kubernetes, definitely we should have some basic idea on Kubernetes. So this is how we are going to run applications in the form of pods in the Kubernetes. What is a pod? If someone asks you what is a pod, pod is the smallest unit that we can create in the Kubernetes, smallest object. There are many objects. There are many objects that we can create in the Kubernetes. Pod is the smallest object among them. Pod is the smallest object among them. So let's go back to our theory. Okay, you see here. There are some advantages. There are some advantages. Okay, there are some features of Kubernetes. So before you understand the features of Kubernetes, let me show you the Kubernetes architecture. This is how the Kubernetes architecture usually. Okay, this is the Kubernetes architecture. We need to understand this Kubernetes architecture. This is the Kubernetes architecture. Okay. So in this architecture, if you look at this architecture, we have two things. Okay, we have two things. One is control plane, the other one is master. Can you see? Here we have two things in this architecture. We are dividing this. You see the first part, the top one, and the below one. Okay. Actually, Kubernetes is like a master node architecture. Kubernetes is a master node architecture. If I take the new one and show you. Master slave architecture. So we'll be having a master machine. As I told you, we'll be having some group of nodes. Okay. As I told you, right? If you are going to create a Kubernetes cluster, we need to mention the Kubernetes. We need to mention the size of the Kubernetes cluster. So if you mention the Kubernetes cluster size, based on the size, the nodes will be created. Consider, I am just taking 4. I'm going to give, okay, let's understand. I'm going to give the size of the cluster as 4. Doesn't mean that I am going to have 4 nodes. Okay, you see, I'm going to have 4 nodes. This is node 1. This is node 2. Node 3. And node 4. We'll be having 4 nodes. Node 1, node 2. If I mention the cluster size as 4, if I want a Kubernetes cluster of size 4, I'll get 4 nodes. Node is nothing but a machine, our server. Node is nothing but our computer, okay? Our server. 4 nodes I will get. So why? Because why we are getting all this, why we are taking all these nodes and all? So usually our pods will run here in these computers, okay? In these servers, our pods will be running. Once we deploy, our pods will be running here in these nodes. So apart from the nodes, there will be one more component called master component, master machine. There will be one more machine called master machine, master node. So what is the Kubernetes architecture? Usually one master node, you'll be having one master node and group of nodes. Okay, one master machine and others will be called as the nodes. That's why Kubernetes architecture is called as a master node architecture. This is a master machine. First one is master machine. First one is a master machine. The others are nodes. You can see in the same architecture. The, the first one, okay, the first one is called as Kubernetes master. The others are called as nodes or minions. The terminology that we use for nodes are, okay, the terminology that we use here is, we will be calling it as node or minion. Both are same. We can call it as node or minion. Minion is nothing but a node, okay? The same meaning. So this is the architecture. Kubernetes, no a master, one master will be there, and based on your cluster size, nodes will be, we are going to create nodes. And what are the components that we have in the master? Just have a look. What are the components that we have in the master machine? You see, these are the components we have in the master machine. Kube API server. We have some components in the master machine, like we have Kube API server, Kube scheduler, controller manager, and etcd. We have these components in the Kubernetes architecture: Kube API server, Kube scheduler, controller manager, and etcd. These are the components that we have inside the master machine. We'll be installing these components in the master machine. And at each node level, we'll be installing some other programs. You see, if I'm saying like these are the components present in the master, what do you mean by that? We'll be installing all these programs. These are all the programs only. So we are going to install a program called, we are going to install a program called Kube API server. We'll be installing Kube scheduler program. We'll be installing controller manager program. We'll be installing etcd program. These are all the programs only. Okay. Once we have the master machine, all these programs will be running inside the master machine. And at each node level, how many nodes we have? See, this architecture says this architecture is having only one master machine and the one node. This is an architecture of one master and one node. This is an architecture of one master and one node. Usually, we will be having, you can see here, we will be having more than one nodes. Based on your cluster size, you can have more than one node. So here we have 4 nodes, meaning whatever the components that I told you, right? So I have a Kube API server, okay? And I have one more component called Kube scheduler. All these components I will be installing: Kube API server, Kube scheduler, controller manager, and I'm also having one more component. You look at the diagram, etcd. There is one more structure called etcd. So all these things will be available, okay? All these things will be available at master machine, etcd folder. All these things will be available at master machine. But at each node level, you see, at each node level, we are having some other components. At each node level, we'll be having other components like kubelet, kubeproxy, container engine. Okay, kubelet and kubeproxy. These things will be available at node level. And the components that are available at node level is kubeproxy, kubelet. Okay, the very first component is kubelet. These are the things available at node level: kubelet, kubeproxy, and we have container engine called Docker. Container engine. Okay, these are the components. Same components. You see, the same components will also be available for node 2. Same components will be available in node 3. Okay, should be. The same component should be available in node 3. The same component should be available at node 4 also. This is how actually the architecture of Kubernetes. You know, in this diagram, we have taken only one master machine and one node. This is the architecture of one master and one node. Usually, these are the components. This is how the architecture will be: one master machine, and based on your cluster size, the nodes will be created. At each and every node, we will be installing all these components. We should have all these components. So while setting up the Kubernetes cluster, definitely all these things will be installed. Now, let's understand the meaning of each and every component. Okay, let's understand the meaning of each and every component. Look at the architecture of this. Look at the architecture diagram. Look at the architecture diagram. We have a very first component called Kube API server. So in the Kubernetes, like if I want to create a pod or if I want to create any Kubernetes object, so far I told you like there are many Kubernetes objects. If any Kubernetes object is to be created, definitely we have to write an YAML file. We have to write an YAML file. So we need to write an YAML file. I'll show you how actually we write an YAML file. There is some format, okay? There is some format for the YAML file. So this YAML consists of some components. We'll discuss about the YAML file in detail, but try to understand that we will write an YAML file. This YAML file consists of all the inputs that user need. So if I'm going to create a pod, or if I'm going to create another object in the Kubernetes, there are many objects I told you, but so far you know about only pod. There are many objects in the Kubernetes. That's the reason why if any object is to be created, irrespective of a pod or a deployment, replica set, ingress object, service object, whatever the object that you want to be created. All these are the objects. Any object you want to create in Kubernetes, you have to write everything, every request in the form of an YAML file. Once a YAML file is written, the YAML file will be given as input to the Kube API server. Who takes the YAML input? YAML input will be taken by the Kube API server. So this Kube API server will act like a receptionist. If you go to any hotel, so there will be receptionist like who will be providing all the information, okay, who will be receiving you and providing all the information. Like the same way, if you write an YAML file, that YAML file will be giving as input to the giving you that YAML file will be provided to the Kube API server. The task of this Kube API server is just to take the YAML and provides the YAML to the Kube scheduler component. Kube API server will take this YAML file and provides the same input to the Kube scheduler component. So now this Kube scheduler component is responsible for doing all the tasks. The Kube scheduler component in the master machine, you see, it will interacts with the kubelet agent in the node machine. The kube scheduler component in the master machine will interacts with the kubelet component in the node machine. So whatever the input that is written here in the YAML file, the same thing will be implemented. Kube scheduler is asking the kubelet agent to implement the same thing. Kube scheduler is asking the kubelet agent. See, all this the kubelet agent in the node machine. We are installing a component called kubelet agent in the node machines. In all the node machines, we are installing kubelet. You see, here we have kubelet, here we have kubelet. In all the node machine, we'll be having kubelet. This kubelet will always, listens to the master. This kubelet will always listens to the master machine. In the master machine, to which component it will listen? It will listen to a component called kube scheduler. It will listen to a component called kube scheduler. The kubelet agent inside the node machine will always listen to the kube scheduler component in the master machine. So try to understand, in the master machine, we are having a component called kube proxy. Sorry, we are having a component called kube API server. Whatever the input that is coming from the outside, okay, user will use the input to the master machine in the form of an YAML file. Let's consider user is writing some with an YAML file called pod.yaml. So the request will comes in the form of YAML. Kube API server takes the YAML file, forwards the YAML to the kube scheduler. Kube scheduler will ask the same thing to implement. Okay, kube scheduler will ask the kubelet agent in the node to implement the same thing. Hope you got it. So this is the actual structure. So we write an input in the form of YAML file. That YAML will be forwarded to the Kube API server. Kube API server will just takes this and forwards to the kube scheduler. Kube scheduler will ask the kubelet agent present in the node machine to implement the same thing. Look at here. I will open the diagram once again. So now the kubelet agent, what this kubelet agent will do? This kubelet agent will pull the Docker image. The kubelet agent will pull the Docker image from this container engine, whatever it is. So we might be storing our Docker images in the Docker private registry. We might be storing our Docker images inside our Nexus repository, wherever it is. Okay. So here container engine can be your Docker private registry, or it can be your Nexus repository, whatever it is. So the responsibility of the kubelet agent is connect with it will connect with the container engine. Okay. It will just connect with the container engine. It will pull the Docker image and it will run that in the form of a pod. It will run in the form of a pod. Try to understand like what is happening here. We are writing a pod.ml, pod.ml, anything for any object. We will write pod.ml, deployment.ml, ingress.ml, service.ml, whatever the ML file you write. So the request first comes to the kube API server. Kube API server forwards that to the kube scheduler. Kube scheduler will always ask the kubelet agent to implement the same. The kubelet agent is asking the container engine. Okay, this is Docker, related to the Docker. Either it is a Docker repository or Nexus rep, whatever it is. We'll pull the Docker image and it will run everything in the form of a pod based on the request. This is the actual process that takes place. So now we know about Kube API server. The task of the Kube API server, takes the input from the user, forwards that to the kube scheduler. That's it. What is the task of the kube scheduler? Kube scheduler, once it has the ML file, once it has the request, kube scheduler will asks the kubelet agent to implement the same. Now kubelet agent will implement the same by pulling the Docker image. See, if a pod is to be created, what actually it requires is it requires a Docker image. Without Docker image, it cannot create a pod. What is written here in the ML file? Our request is to create a pod. To create a pod, usually we need a Docker image. So kubelet will pulls the Docker image, will gets the Docker image from here, and it will create the pod. And here we have few other components like kubeproxy. Once a pod is created, each and every pod will be assigned with some IP address. Each and every pod that is created will be assigned with some IP address. Each and every pod will be assigned with some IP address. Each and every pod will be assigned with some IP address. So which component's responsibility it is? Like there is a component called a kubeproxy. Kubeproxy will assign IP address to the pod that is being created. Once a pod gets created, kubeproxy component will assign an IP address to the pod. Kubeproxy component will assign an IP address to the pod. Right now we have another component here. You see, there are two more components in the master machine. Like one is controller manager, other one is etcd. There is one more component called controller manager and etc. Two more components. Okay, controller manager and etcd. So this etcd is a component. It is like a storage. It is like a cluster storage. It maintains information. This particular one will maintain the information about the entire cluster. Usually, we will use some kubectl commands here. Okay, we can interact with the Kubernetes cluster and we can run some Kubernetes commands. For example, if I want to see what are all the pods running, I can simply run a command called, kubectl get pods. I'll simply run a command called kubectl get pods. So if I run this command, it will display the pods that are running. So from where it gets the information? It gets the information. There is a component I told you. There is a component called etcd folder. There is a component called etcd in the master machine. So when I run this command kubectl get pods, usually it gets the information from the etcd only. Okay, so it maintains the entire information about the cluster. So usually if I run any command like kubectl get nodes, okay, get pods is already done, get nodes, meaning I would like to get the nodes information, how many nodes are there, like that. If I want to know about nodes, yes, I'll run a command called kubectl get nodes. Definitely, I will be interacting to the etcd. So this will get interacts with the etcd. It gets interacts with the etcd, and we will be getting the information from the etcd. So etcd is a folder. etcd is a kind of storage. It is kind of a data storage in the master machine. It stores the entire cluster information. We have cubes. Okay. Whenever I run the commands, I'm getting this information from etcd. It's fine. So what is another component we missed? We have another component that is missing. We understood about all the components like kubelet, kubeproxy, container engine. We have another component called controller manager. So this controller manager is present here in the master machine. There is an advantage with this controller manager. The task of this controller manager is like it always it always check whether the actual state is desired. It always make sure. This controller manager will always make sure whether the actual state is equal to the desired state or not. Controller manager will always make sure whether the actual state is equal to the desired state. What do you mean by actual state and what is the desired state? Consider in the YAML file, okay? In the YAML file, user is mentioning that he need two replicas, okay? He need two bots. Consider user is writing a file called, let's see, user is writing a file called deployment.yaml. I told you, right? There can be, user can create any object by writing an YAML file. Consider user is writing a deployment YAML file. User is writing a deployment YAML file. And inside this deployment YAML file, he has mentioned all the requirements. So one of the requirement is like he need two replicas. Inside the deployment file, he mentioned he need two replicas. What do you mean by two replicas? Two replicas are nothing but two pods. He need two pods. Inside the deployment file, he mentioned that he need two replicas. Okay, so based on the requirement, two replicas will be created. Okay, based on requirement, two replicas will be created. But try to understand, suppose if something happens, any of the pod, if something happens to any of the pod, and if any pod gets crashed, immediately a new pod will be created. Okay, so user has requested in the deployment.yaml file, user has requested for two pods. He need two replicas with the same Docker image. With the same Docker image, he need two pods. So anyhow, it is going to create two pods. Based on the requirement, it is going to create two pods. Suppose if something happens to any of the pod, controller manager, the responsibility of the controller manager will always make sure the controller manager will always make sure whether the replicas are running as per the user input or not. User is requesting for two replicas. It will always make sure the two replicas are running or not. If user is requesting for three replicas, it will always make sure whether three replicas are running or not. It will always make sure whether the number of replicas requested by the user is created, running or not. If something happens to any of the pod and if a pod is deleted, even if we intentionally, if I go and delete one pod, immediately a new pod will be created. Intentionally, if I go and delete one pod, a new pod will be created. Why new pod will get created? Because user has mentioned two things. User has requested for two replicas. And controller manager is keep on monitoring. Controller manager responsibility is to keep on monitoring what is the user input. User has requested for two replicas, then definitely the responsibility of the controller manager is to look after whether two replicas are running or not. That is a that is how the controller manager will always take care of the replicas. Okay, if two replicas are running, if I go ahead and delete one pod, definitely immediately it will create one more pod because in the YAML file user is requested two pods, and if only one thing is running, definitely it will go ahead and create second one. So whose responsibility is the controller manager? In the YAML file, the controller manager will take the responsibility. Controller manager will always make sure whether the number of pods are running based on the user request. So this is the architecture of Kubernetes. Okay, this is the architecture of Kubernetes. Hope you understood. You can go through once again, and you can see like what is the components. Okay, what are all the components present, and what is the task of each and every component. Let's come here. So why we are using Kubernetes? The very first thing. So far, I have given you some basic details about the Kubernetes. If you understand, the main feature of Kubernetes is load balancing. You see, we are creating more pods. More pods, you see, we can create 4 pods, 5 pods, 6 pods, any number of pods. It is up to you. If you have the capacity, if I have the capacity in the sense like machine capacity. If I would like to create one pod, definitely it requires some resources. What are the resources it requires? It requires the memory, it requires CPU. Two things it requires. If I would like to create one pod, definitely two things I require. One is memory, the other one is CPU. So without these things, I cannot create pods. If these resources are enough available, if these resources are available, definitely I can create any number of pods. We can create any number of pods if the resources are available. Resources are nothing but memory as well as CPU. And the Kubernetes main advantage is like load balancing. Load balancing. We can create any number of pods so that each pod can able to handle some load. If I'm getting some 100 requests, first I will create only one pod. Why? Because single pod can able to handle 100. I'm taking an example. It doesn't mean that each and every pod will handle only 100 requests. Okay, don't go for that pod. I'm just telling that one pod example. This is an example. Okay, usually single pod can able to handle some more than 500 requests. Sometimes based on the application size, based on the nature of your application, based on the nature of the application size, pod can able to handle the traffic. For example, if pod is able to handle only 100 requests, and if 200 requests are coming, then definitely we have to create two pods. And if we are getting more load, then we will be creating more pods. Usually, we don't need to. It has a concept of auto scaling. It has a concept of auto scaling. Anyhow, it balances the load because we can go ahead and create multiple replicas. If I want some 5 replicas, yes, I can create 5 replicas. And it also has the capacity, it also has a feature of auto scaling. What do you mean by auto scaling? Consider I have only 5 replicas running. Each replica can able to handle 100 requests. Totally, it can able to handle 500 requests. All of a sudden, if the traffic increases and if it requires more pods, definitely we can enable auto scaling. We can enable auto scaling. If you enable auto scaling, based on the load, the number of pods will increases automatically. Based on the load, you can increase the number of pods. Based on the load, you can increase the number of pods. Say we are not going to do it manually. It is an auto scaling. Automatically, if the load increases, it will increase the number of pods to handle the load. Try to understand what is load balancing and what is auto scaling. We are having multiple replicas to balance the load. We are having multiple replicas to balance the load. And we're also having a concept of auto scaling. Auto scaling is nothing but automatically increasing or automatically decreasing. Auto scaling means increasing or decreasing, automatically increasing or automatically decreasing. What it increases and what it decreases, it increases the number of pods. And it also decreases the number of pods based on the requirement. If the load increases, automatically increases the pods. If the load decreases, automatically decreases the pod. That's the concept of auto scaling. And I told you, right? New containers will be created in the form of deleted. New containers will be created in the place of, I already told you, if I go ahead and delete any pod intentionally, always remember, user is mentioning that he need some 3 pods or 4 pods in the YAML file. If I go ahead and create any of the pod, definitely new pods will be created in the place of crashed pods. We will not use the terminology called container. If you want to understand, I don't want to confuse you. As per the concept of Kubernetes, new pods will be created in the place of crashed pods. If any pod is deleted, if any pod is crashed, if any pod is not working fine, if I go and delete the pod, then the new pods will be created in the place of old ones. That is called auto healing. You don't need to heal it. Automatically, it will heal by itself. It will heal by itself. New pods will be created in the place of crashed pods. If any pod is deleted, new pod will be created automatically. Hope you understood all these 3 things. Load balancing. Kubernetes is having an advantage of load balancing. We can create more replicas to balance the load. Whenever we need more replicas, it has the concept of auto healing, auto scaling. We can enable auto scaling so that based on the requirement, the number of pods can be increased or decreased. It also have an advantage of auto healing. Auto healing is nothing but new pods will be created in the place of deleted pods or crashed pods. Okay. And you see, the main point is that it is an orchestration tool. Kubernetes is a container orchestration tool. What do you mean by orchestration? Orchestration is nothing but clustering any number of containers on different hardwares. You see, if you want to create any replicas, you can orchestrate. You can orchestrate any kind of things, any kind of pods, any number of pods, clustering any number of containers on different hardwares. If you want to have a 4-node cluster, you can take. If you want to have a 5 nodes cluster, yes, you can take. If you want to have a 10-node cluster, you can take. And you can deploy all your services in the form of pods in the cluster. Cluster is nothing but a group of machines. What do you mean by orchestration? Orchestration is nothing but you can create a cluster, and inside the cluster, you can have any number of nodes. And inside a node, you can run your application in the form of a pod. Try to understand the Kubernetes basic concept first. Hope you understood. First, we will create a Kubernetes cluster. Inside the Kubernetes, usually you understood the Kubernetes concept, right? One master machine will be there, and you can have any number of node machines. Consider all these are the nodes. Okay. Sometimes based on the requirement, you can have a 5-node cluster, 6-node cluster, a 10-node cluster, whatever it is. Consider I'm taking some nodes here. 1, 2, 3, 4, 5, 6, 7. 7 nodes. Okay, I've taken 7 nodes cluster. And you can take like so inside the node. This is the node, okay? This is the node. The whole thing is called as cluster. And inside we have nodes. Consider this is node 1, okay? And what is this one? This one is called master machine, master node. This is a master node. This is master. And inside the node, you see, we can create any number of pods. You can create a pod 1, pod 2. You can see this is not in the node 1. We have many nodes, right? You can create pods in any of the nodes. Usually, if you have the capacity, if you want to create more pods, you can create a big size cluster, and you can create any number of pods. Creating pods is very easy stuff. Like you should have the enough resources to create the pods. That's the only thing you need to understand. To create a pod, we should have resources. What do you mean by resource? CPU and memory. We require CPU and memory to create the pod. We require CPU and memory. Okay, that is the only thing you need to understand. Okay, this is the basic thing that I would like to discuss on the Kubernetes part. We'll see the practicals in the next sessions. Any questions you have, we'll discuss. Otherwise, we'll stop this for today.